Hello students, welcome to Mechanical E-Learning. Today we'll be discussing about different types of loads and beams. So there are different types of beams available, which are cantilever beam, simply supported beam, overhanged beam, continuous beam, and propped cantilever beam. First one is the cantilever beam. Uh, the cantilever beam is the type of beam where one end is fixed and other end is free. The fixed end will restrict the horizontal movement, the vertical movement, and the rotation of the beam. So the reaction will be generated a horizontal reaction, a vertical reaction, and a movement in case of fixed end. Okay, so you can see in the diagram, here at the fixed end, a horizontal reaction is there, a vertical reaction is there, and a movement is there. Next is the simply supported beam. So these are the type of beam where both ends are supported by different type of supports. Here the left end is supported by a pin or hinged support and the right end is supported by the roller support. The hinged support or pin support will restrict the horizontal movement, the vertical movement and the rotation of the beam. Okay, here in the right side there is the roller support. A roller support will allow the horizontal movement of the beam, but it will restrict the vertical movement. It will also allow the rotation of the beam. So in case of roller support, only vertical reaction will be generated. In the left side, you can see there is one horizontal reaction and one vertical reaction as it is restricting these movements. In the right side, as it is a roller support, uh, as it is only restricting the vertical movement, so only vertical reaction will be there. Okay. The next is the overhang beam. Overhang beams are the types of beam whose end portions are extended beyond the support. Okay, so it can be of single overhang, it can be of double overhang. Single overhang means one side is overhang, means one side is beyond the support, and in case of double overhang, both the side will be beyond its support. Okay, so it is called as your overhanged beam. Next is your continuous beam. Continuous beam means there are two or more supports which are available for the beam. Here you can see in the diagram, here there is 5 supports available for the beam. Next is propped cantilever beam. We know that cantilever beam means one end is fixed and other end is free. In case of propped cantilever beam, here one end is fixed and other end is supported. Here in the figure, the right end is supported by the roller support. So that means the reaction will be generated vertical reaction. In case of fixed end, vertical reaction, horizontal reaction, as well as the movement will be available as it is restricting these three. Okay. First one is point load. Point load means the load will be acting at a very small distance. Okay. Okay. Here you can see in the diagram. Here there are 3 loads which is acting at the beam. Okay. This type of load will be considered as the point load, where the load is acting at a very small distance. This small distance can be considered as a point. Okay. Next is a uniformly distributed uniform load, which is acting over the full span of the beam or a distinguished section of the beam. Okay, so this is called the uniformly distributed load. Here you can see the UDL, that means uniformly distributed load, is acting over the full span of the beam. Okay, here in this case, we can find one equivalent load. Okay, that equivalent load will be acting at the mid section of the area where the uniform load is acting. Equivalent load will be equal to load multiplied by the distance where it is applying. Okay, here you can see it is W multiplied by distance, that is L. Okay, here you can see the load, that is W into L, will be acting at the mid section of the beam, mid section of the area where the uniformly distributed load is acting. Okay. Next is the uniformly varying load. So uniformly varying load means the load will be varying throughout the beam. The load will be varying throughout the beam uniformly. Okay. That can be considered as a triangular load. Here you can see the load is varying from 0 to a certain distance. Okay, so in this case also we can find one equivalent load which will be equal to area of the triangle, that is equal to half into W into L, half into load into length. Okay, it will be acting 2/3 from the base end. Here you can see in the diagram, this equivalent load, that is half into W into L, is acting from 2/3, that means 2L by 3 from the base end. Okay, so this is called the uniformly varying load.